This is a first video in a two-part exercise where we'll be going over how to create a circle mesh without using Blender's built-in circle mesh operator. And if you stick around, I'll show you some exercises that you can use to solidify the knowledge of the topic we just covered. Hi, I'm Victor Stepanoff. I'll be guiding you through this beginner Blender Python exercise. In today's video, we're going to be covering how to get the coordinates of the circle mesh vertices. This topic was inspired by one of the comments in from my previous exercise video. Thank you, Radar, for suggesting this topic. Without further ado, let's jump into the exercise. Our end goal is going to be creating a circle mesh. So let's start with that, go into Blender and see what it's going to look like so we're all on the same page. I'm just going to open Blender and select everything by hitting A and then AX delete and deleting everything. Next, I'm just going to hit Shift A and then Mesh and then Circle. I'll hit Tab to go into edit mode and look at all the verts and edges of this particular circle mesh. So we're going to be, in this video, we're going to be getting the coordinates for all these verts, right? And in the next video, we're going to be connecting these verts that we get in this particular video. What do we need to start off with? We need some way of determining these positions. And a good way to do that is to use the equation for a circle. Let's head on over to Wikipedia. In Wikipedia, we can see that the circle mesh equation for a unit circle is this right here. And we will actually be using the parametrized version that uses cosine and sine to calculate x and y, right? Where this t parameter goes between 0 and 2 pi. Let's see what that looks like on a graph. So here we can see the parameterized circle equation getting drawn on this graph. We're using cosine to calculate the x and sine to calculate the y. And we're going from 0 to 2 pi. Well, the parameter t is going from 0 to 2 pi. For example, you can change. I'll provide a link in the description to this particular graph so you can play along at home. So if you change this to, for example, just 1, the graph starts like drawing between here and here, right? You can see that if we just increase this by 2, we continue going around. Like maybe let's draw it to 6, right? And it's almost there at the beginning, right? Making a full like 360 loop. And if you use 2 pi, which is exactly the full circle, you'll get this drawn right here, right? You can actually also use just tau as well to do the same exact thing. Also, here's a more interactive version where you can actually see the exact point. So it's not clear exactly like how the point is calculated, but in this particular version of this graph, you could actually interact with it with this point right here. I'll also provide a link in the description so you can like drag. So this is what we're going to be doing with Python. We're going to be kind of like dragging this across and recording these positions, right, with x and y, right? So this is exactly what we plan to do with Python. So now let's jump into Blender and do this. All right, now we're back in Blender. I'm going to hit Tab to exit out of edit mode and then just hit X and then delete that circle. We're going to head up here into the scripting workspace, hit scripting and then hit new to create a new script for us. So as you can see from the previous exercise, that we usually import some stuff at the beginning to allow Python to control Blender. We'll need some math functionality to get the sine and cosine. And we're just going to calculate the x and y. And let's draw, for example, a sphere to indicate where exactly we just calculated the coordinate, right? Let me write down this as comments so we can fill this out as we go. All right, this looks pretty straightforward, so let's start filling this out right away. So to give Python access to Blender, we need to import BPY to to extend Python's functionality with math. Think of like you're extending Blender with add-ons. Python you can extend with modules, and in particular we need the math module. Next, if we look at the equation, we have the t parameter. So let's create that t parameter for us to work with. Of course, I usually don't like to create variables with a single letter because it's usually bad practice. You probably would only want to use this in for loops just because it's hard to understand this like later when you're coming back to the code. But for the sake of looking at the current circle equation, let's keep it as a single letter for now. Next, we'll need to get the sine and cosine. Let's actually go into the interactive Python console, import math, since math, so we're importing here, right? But it's a whole, like this is the script and the interactive Python console is a separate thing. So we need to import math here as a separate thing, right? So math sine, for example, and you can see that it returns this particular function returns sine. And let's just put in a number. So like that's, for example, the sine of 0.1. Let's do the same for cosine. Right, the same. I'm pressing, by the way, a tab to get this doc string, like documentation string. So it'll tell us a bit more about what this function is doing. So let's put that there as well. All right, so let's just copy this over here where we're calculating the coordinates, right? So like that, right? So this is X, right? And this is Y. Let's go. Oops. So let's use T right here and T right here as well. So that's X and Y. And to this is all great, like we can like run it right now. The script runs, but nothing really happens because we're not using these X and Y coordinates, right? So just Blender reads all of this, or not Blender, Python reads all this, executes it, and nothing happens because we're not using it. Let's use that by creating something that we can see in the 3D viewport. I'm gonna just go in the 3D viewport and hit Shift A to add a mesh. We're gonna add like an icosphere just to visualize this. I'm gonna set the radius to 0.1. It's right here. I'm gonna go into the info panel down below under the interactive Python console. I'm gonna hit copy, right, and I'm gonna paste this right here. I'm gonna remove everything from these parameters, these extra parameters, except the location, because that's what we want to see, right? This is going to be our kind of visual way of telling what exactly, like what the X and Y for a given T is. So let's replace the X and the Y. So we're using the variables that were calculated right here and just putting them into the location, right? I'm gonna clear the scene and let's run the script. Right, now as you can see, we got this icosphere placed right here. So this is right after we executed this script. Let's change this from 0.1 to 0.3 and run it again. Notice that I'm not removing anything from the scene. Go ahead and play around with this and see like the different what locations you're going to get when changing this particular T. So, and don't clear the scene so you can see and like follow along, like where a particular circle, or sorry, icosphere gets placed. All right, now let's repeat this code over and over again to get different locations for this icosphere. I'm gonna create a new for loop right here. And let's repeat this code like 10 times. I'm going to select all of this and indent it. So tell Python that we want to repeat this particular part of the code. So I'm going to hit tab, right? It's going to move everything under this for loop. And let's run it. So I'm going to clear the scene. So hitting AX and then delete. And let's run this. Nothing really happened except we added 10 icospheres. You can look into the outliner right here. There's 10 icospheres and they are all in a single place. So I'm going to hit G to move, select, and then move, hitting G, right? So everything just constantly gets placed into the same place. We don't really want that. This happens because T is always equal to the same exact number. To fix that, let's create a step. Oh, let's do that. And from previous videos, you've seen how I've used step in a for loop. Let me just quickly show you this in an interactive Python console. So I just pasted the for loop here, and let's print out the I. So I goes from 0 to 9, right? So it looks at what the range here is. It's to 10, so from 0 to 9. And I'm going to use like a step, and then let's put it equal to that. I'm going to repeat. I can repeat the code in interactive Python console by hitting the up arrow on your keyboard, right? So it remembers what you typed in before. I'm gonna write I and multiply that by a step, right? And we get a different value each time. So we're just gonna do exactly this right here. So we're gonna start with I equals 0. Then T will be 0, right? 0 times whatever step is going to be 0. And we're going to just loop over these different values of I. Let's do that by deleting everything and running the script. Oh, you can see that we now have these particular icospheres, right? They've changed location on each iteration. Let's see how maybe we can create a full circle. Let's type in like, I don't know, 150, right? Let's delete all of this, so rerun it, right? Got the scene looking like this, right? Not a full circle, maybe, I don't know, 200, right? Let's delete that, right? Almost there. And let's set it to 10. Right, oh, like that looks like that connected. Well, that's all great, but this won't work. This won't scale, right? This won't work if we change the step. So let's just change the step to 0.01, run it, and look at that. We gotta calculate this range here, right here, right? It's going to get old pretty fast. To fix that, we need to go back and look at what we're going to be going for, exactly what the circle is going to look like. I'm going to select everything. I'm going to hit Control Space, and I'm going to add a circle mesh, right? I'm going to hit Tab to go into edit mode, and as you can see, all these verts in this circle mesh are dividing the circle into parts or segments, right? And we know that from that equation that t goes from 0 to 2 pi. So we need to divide, so all of this we need to divide by however many verts we want in our circle. Let's see how that looks. I'm gonna exit out of edit mode by hitting tab again and then deleting that circle. So let's create a vert count and set that to 32, right? And then set the step to 2 times math and then pi, right? You can get the pi constant through the math module by using this. So you can actually look at in the interactive Python console right there, right? 2 pi or pi. And then we need to divide this by the vert count. The range is not going to be that. The range is going to be, so now we have the step dividing 2 pi into however many segments we have depending on the vert count. So now we need to use the vert count as the number that we're going to put into the range. And now let's run this. And look at that. Now we have evenly set up these verts because of this particular step. We can set this to 16. I'm going to delete everything by hitting AX and then delete. Run that script again. Now we have 16 even segments, right? Let's do that again, and like maybe it's not going to work with 64, but let's check. And hey, look, it works. It still works with another number of verts. Now let's update the variable names because I want them to be a bit more readable. And we'll start with the step right here. You can think of it as an angle step. And so I'll need to update here. And T would be the current angle, right? This is a bit more readable in my opinion. You can replace it right here. Let's delete that, set this to 32, and make sure it still runs, and it does. That looks a lot better to me. Also, as an option, you don't have to do this, but you can use, instead of 2 pi, you can use tau right here. And it is also available through the math module, and it's gonna achieve this exact same result right there. So let me update these comments. Now that we have all these coordinates calculated, we need to create a list of these coordinates. And to do that in Python, we're going to be using list data structure. Let's go into the interactive Python console right here and type in list in the and hit enter. So you can define a list through calling list, or just these square brackets like so. You can also put something in a list by just comma separated values like so. So you got 3 numbers in there. Let's create a list called L and assign that list to the variable L. And you can use append to add objects to a list. So let's do just that. So now we have 1 in there. Let's put, I don't know, 33. Let's look at L, right? And like 42, for example, right? Oops, oh, that was a bad move. I just deleted the list. All right, let's do that again. So 42, 33, and then 1. And as you can see, the order does matter, like which in which order you add the elements. All right, so let's create a new list right here and call this function so it's really readable that what we're creating here. Let's just copy this right below. Use append, and in particular we're going to be interested in this location, so we're going to just copy this tuple right here, right, the x, y, and z, and we can print the results. So we're going to output this into the console, and let's run this. On Windows, to see the resulting print, you can go into Window and toggle System Console, like so, and you can see that we have these list of tuples, right? It's not super readable. To get this console on Mac and Linux, I have a separate video for you that if you want to follow, you can, and also get a similar console to see the output. Let's update the code just a bit to make it this a slightly bit more readable. And I'm gonna import another module, pprint, and use that down here. So pprint.pprint. Let's clear the scene and let's run it. And now, instead of the list being all jumbled up in a single like line, right? We have each of these tuples separately spread out on a given line. Make sure to hit the like button if you're learning something new today and you want to see more videos like this. Let's finish off by adding some comments. So we're going to be extending Python's print functionality with this print, right? And we're gonna create a list of verts, right? All right, and as promised, some exercises for you to solidify this particular topic. The first exercise is going to be creating this scene using this particular script. I'll give you a hint in a couple of seconds after you pause. So if you feel you're stuck, it's okay. Just unpause it. I'll give you a hint and then show you the full explanation. So pause the video now. Okay, for your hint, notice that the z-coordinate changes with every single iteration of the loop. All right, I hope you got that. Here's how I would do this particular scene. So I'll just add a step, a z step. And I'll just calculate the z right under here. So I'm gonna just multiply, I'll actually step and multiply that by I and put that z right here. So let's delete that and run the script. All right, here it is. All right, I'm gonna clean that up for the next exercise. All right, and for your next exercise, how do you change the radius of this circle? So write down the code that will allow you to control the radius of the resulting circle. This might be a bit more challenging and you might need to Google a bit how to change this in this particular equation. I'll also give you a hint like 5 or 10 seconds after you pause. So you can pause it, try to do it on your own. I'll give you a hint, don't worry. So pause the video now and try it. All right, as the hint, I've provided a link to a math explanation for this equation. And in that video, there's going to be the answer. So watch that video to get what you need. All right, so I hope you were able to get that radius, and I would just do it like this. So set that to 2, and I'm just gonna go right down here and multiply this. All right, and I won't delete anything from the scene so we can see the difference between the unit circle and a radius circle with a radius of 2. So let's just do that. Let's, I don't know, do 0.5, right? I hope that you learned something new today, and you'll join me for part 2 of this exercise where we'll be connecting the dots. And for more videos like this, make sure to subscribe. Thanks for watching.